AIChE-VIT initiated podcast. I am Leah,
And I'm Nikhil.
and today we are excited to welcome Ms. Bhadra Hrishikesh. She's a solution consultant at Time Corporation in Japan. She has prior experience as a process engineer at Toyo Engineering Corporation. She also completed her PhD in chemical engineering from IIT Madras. Welcome, ma'am.
Thank you.
We are glad to have you here, and we do look forward to have a meaningful conversation. How, ma'am, first of all, how do you feel being part of this podcast?
Thank you so much for having me over, Leah and Nikhil. And I'm excited to answer your questions, and it's an honor to speak to junior chemical engineers.
That's nice, ma'am. And we are moving on.
Hmm.
As a solution consultant at Arts Corporation in Japan, is chemical engineering a good bet for jobs in Japan compared to other engineering branches? And what short courses can boost a graduate's chances there in Japan?
Okay, so um, I don't think there is a good or bad when it comes to engineering disciplines. But anyway, as chemical engineers are, as far as we are concerned, recently, Japan is focused more on the carbon neutrality achievement by the year 2050. So, Japan's government is having basically many goals of achieving so much tons of carbon storage per year in various locations across Japan and so on. So, basically, they are moving on to net zero greenhouse emissions. So because of that, there are so many projects that are coming in within Japanese companies as well as with collaborations between companies and academia. So because of that, it's a good time for chemical engineers to use their knowledge base and extend their support to various projects in Japan. So that's one thing. And more importantly, as far as courses are concerned, I think that Japan mostly focuses on postgraduates, as I was saying. In India, there is a trend to just directly join the job after the BTech. But in Japan, most of the engineering disciplines they take you in after your masters. So it's a common trend for Japanese students also. After BTech, they will do their masters in various related disciplines and then join a company or even go for PhDs after that. So, obtaining masters is one way of coming to Japan and joining a company or academia. Another way that I was discussing was this internships. There are many internships offered by universities, which is an all expense paid kind of internships. There are many portals that you can look into. As I was saying, there are internships offered by University of Tokyo, then OIST, that's a very reputed research institution, and I think METI also offers internships. So these kind of programs, it's like for 3 months or so, where you can get accustomed to what it's like working in such environments. Even companies offer internships and after placements after. In IITs, I have seen that trend also, where students go for internships in Japanese companies and get placed afterwards. And one important thing, basically, like as a starting point, is to learn the language. As these days, as I was saying, there is a lot of focus on this nationalist kind of movements in all countries. Just like that in Japan, also, they are making visas more stricter. They are including Japanese language as one of the requirements for visas and so on. So learning the language is an important thing uh, as a first step for coming to Japan. And other than that, these kind of opportunities can be made use. to start your career in Japan.
I'm sure more of our listeners will take care of these key points to, pursue their opportunities in Japan. Speaking of opportunities, how crucial is industrial experience for chemical engineering students aiming to join companies like Toyo?
So, as far based on my experience, uh, I think the they don't really look for previous experience unless you are a mid-career joinee. They don't really, if you are a fresher or fresh graduate joinee after your master's, they don't really look into how much industrial experience you have. Uh, for example, in my interview, they focused mostly on how I fit into the company or how what my project was on. They did not look into what kind of industrial experience I had. They will be mostly looking into your aptitude on how you will fit in a Japanese company. So basically, culturally, it's a bit different when compared to it's a bit more strict and it's a bit more, what can I say, disciplined is one word of looking, but one way of looking at it. But yeah, it's a different culture. Basically, company culture is a bit different. So how you accommodate to it is how you fit into with your colleagues is very important for any company. So they mostly look into that aptitude as well as your academic, how much marks you have, or they usually have a test also, test and some group discussions that's the usual process, or how well you do in that. They will just be looking into basis, a basic thing, but how well you perform in your interview is more important.
So, cultural accommodation is very important, right, ma'am?
Yes, 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 yes. It's important for them to trust you, basically. That's very important. Trust is a very important word when it comes to Japanese companies.
Okay, ma'am. Moving to the next question. I have heard that in Japan, professors often have lifelong ties with companies like Mitsubishi, Sumitomo. How can an international fresh graduate leverage their professors' network to transition into a corporate R&D role there?
Like I was telling, all these carbon neutral projects are coming in, and many of these projects are funded, especially in some of the universities. There are collaborations between these kind of companies and the industry. Let it be Mitsubishi or Honda or any other important Sumitomo Mitsui, any sort of companies, they will be having industrial academic collaborations with your lab. So when I basically did my internship with University of Tokyo during my time in IIT. I had an exchange collaboration with the University of Tokyo. So my lab itself had collaborations. They were being funded. Some projects that were being happening in the lab was being funded by some of these kind of companies. So I think when it comes to, if you have worked in such projects, they will consider you, or they will at least consider you for interviews at least. I think that is a possibility when it comes to working industry collaborative projects. So even there are people who in Toyo also had connections with certain universities, and their projects, based on how they do their projects with the company, they will take you in for the role. So international students can also make use of such opportunities.
Like we say, communication and networking is the primary key.
Of course. Yes, definitely.
Okay. So I've heard of a new trend in Japan. Japan is currently leading a shift towards materials informatics, AI-driven chemicals research. For an international engineer, is the technical work in Japan more focused on this high-end simulation, Or is there still a better emphasis on Genba, that is on-site mastery of hardware and pilot plant operations that we see in traditional firms?
I'm actually not very familiar with this one. So I can tell you from my experience, from because I have not uh, worked on, what can I say, the hardware part of it. Basically, I do not have experience with like you said, pilot plant operations or on field experience. I don't have such experiences. So when it comes to at least the kind of projects that I have been working on in simulations, I focused on simulations. So it's not necessary that you need to have on field experience. It depends on the kind of industry that you're working in, basically. So if you are in EPC industry, like Toyo, for example, there, as you know, there are what can I say, the it depends on your role, the role that you are in. As a, if you are a process engineer, you will be of course responsible for as I have worked as a licensor previously for the urea technology. You will have certain development of material balance, and such calculation parts will be done by the process engineer. Again, you are not still on the field, you are working in your office, you don't have interactions with the field. But this the design of such equipment, these kind of things will be done by you. But and finally you will develop the P and ID. But the next step, which is even the procurement part, that is also, that is when you talk with vendors. For example, you have to buy a heat exchanger, or you have to buy a reactor. These kind of interactions happen with the vendors. Then in the next part, if you are in the construction, and then the after the construction part also, the chemical engineer does not have much role in the construction part. When it comes to, what can I say, commissioning and startup, which is a final role for the chemical engineer, that's when you are actually in the field. You have to have, you will be trained, you will be working with operators of your plant, you will be taking in data. You for if you are in an EPC company as a licensor or somebody who has the technology to build something, it's usually a what can I say, something called as performance guarantee, where you promise the client that this much ton of urea or this much ton of ammonia will be produced. That's a promise, and it's a responsibility of this process engineer and the commissioning team to make that happen. So in that situation, you need that on field experience, and that again you will be gaining on the job. You do not need a prior experience to get into that job. You will be trained. If you come into the industry, you will be trained to do that. But when you are in a role that's like mine, which is currently as a simulation person, you don't necessarily go on field, or you don't have any experience on field, but you will be helping the companies go towards projects, I mean supporting those projects which involve finally constructed into the field or into the operation. And I think it depends on the, like I said, to conclude, it's basically depending on the kind of role that you are in, whether you need on field experience or you can just focus on your knowledge. Did I answer your question? I'm sorry.
Yes, ma'am. So roles depend.
Yeah, it depends on the kind of roles that you are into. And like I said, prior experience is not, it's not necessary. Some things you learn on the job.
Yes, ma'am. So academics and industrial experience are both different.
Yes, yes. It can go hand in hand also at some points, depending on the kind of projects that you work in. I mean, and I think the important point is to have, like as undergrads or when you are transitioning to a postgrad, the important thing is to have transferable skills.
Mhm.
So, for example, I worked during my PhD, I worked on simulations. but I had a totally different approach. I worked on molecular simulations, which I'm not using now. Like I work on Aspen softwares now, but I think important thing is I was into coding. I was into uh, what can I say, other skills. Like there are things that you develop during your masters or during undergrad, where you do a project on how you manage things, literature search, or how you interact with people, or language, or the way that you present your results. All these small things, these are the transferable skills that you have. So coding, things like, especially in this kind of where people are focused on AI and stuff, so it's more important that you also learn how to make use of it, and to make AI work for you, as well as develop coding skills and such kind of knowledge which is transferable. So even if you do have a background in a slightly different area, your skills are transferable. You can fit in a new company also, or a new research background also. So as long as you have transferable skills, it doesn't matter. It's okay. You can focus, or you can try out different things.
Talking about AI, the future, we are going to
Yeah.
talk about the future of Japan. By 2050, Japan has committed a carbon neutral environment,
Mhm.
right? How
Yes,
has
yes,
this
yes.
shifted the focus for chemical engineers there? Are we seeing more demand in green hydrogen and carbon capture versus traditional chemical engineering methods?
Yes, yes, of course. So I think so. Previously, when somebody comes in for a client wants to do a project, they just look into the capital investment, which is the capex, the operating cost, which is opex. That's it. But recently, the shift, there is one more point, which is carbon intensity. That's something that industries or the customers themselves are going into. So that's basically the tons of CO2 that you emit per the ton of CO2, ton of product that you make. So recently, because of many climate agreements and conferences that are going around, there are many intensives that is given to these kind of companies if your carbon intensity is met, or if you have less emissions, if you are focused on, if you have less carbon intensity. So when such things happen, all the industries, whether it is the EPC company or whether it is any manufacturing industry, more they are focusing on research. They are focusing on development of technologies that enable you to do this. So what happens is, I mean to so because of that, chemical engineers need more knowledge about, what can I say, many projects focus on these kind of aspects also. It's not just making ammonia or just making urea. There is the concern about how much carbon you are emitting, or how much energy that you are using up, or what kind of feed that you use. All these things become very important. So focus is shifting. And one example is, I can see that many major companies are, so when it comes to, for example, in my job, I have clients that come into on a recent project. They wanted to do carbon capture. So they approach us, they give us their conditions, and then they tell you, give us, so you please use your simulations to understand, to compare how much energy is released. Or there are tools available for cost comparison in the products that I use, if in Aspen's products. So because of that, they want an economic analysis to understand which technology will be profitable as well as less energy intensive. So, for example, I recently work on adsorption technologies. So there are people who compare what, like, which is better. Is it absorption, AB, absorption is better, or adsorption is better? So people use these kind of simulations even before their it's basically the job before the EPC. So they want to compare different things and then focus on the option that is economic as well as carbon neutral. So most of the companies are investing in such projects, and there are organizations also in Japan, which is one of them is NEDO. It's what can I say? New Energy and Industrial Technology Organization, Development Organization. So these kind of it's basically a non-profit organization focused on these kind of carbon neutrality. So they have funds which they distribute across industries to develop such projects. So when such large number of such projects come, there is obviously demand for more people with the set skills, or these kind of, what can I say, approaches are becoming more and more common. So yeah, it's a good time to be a chemical engineer, at least now.
Yeah, we hope so. A big thank you to Ms. Bhadra Hrishikesh for taking the time to share her journey and insights with AIChE-VIT. Your experiences working in Japan and your perspectives on industry, research, and emerging technologies were truly inspiring for our students. We're grateful for this engaging conversation, ma'am.
Thank you so much.
And to everyone watching, if you enjoyed this episode, don't forget to like, share, and subscribe to Chemically Doped for more such conversations. Thank you and stay tuned.